This is Mel and Kerry, and our geology final presentation is to share with you all information about Idaho's belt series.
First and most important are the locations of the belt series. Currently, the belt series are only visible in these three areas of Idaho: the northern peak, central eastern border, and the southeastern border. However, the belt supergroup extends from other supergroups in Canada down primarily into northern and central Idaho and western Montana, with a smaller extended portion in eastern Washington.
Since Idaho belt series is such a widespread province, there are many different structural features throughout the series. Common features of the series are mountains and outcrops created from thrust faulting. A thrust fault is similar to a reverse fault in that the footwall moves down and the hanging wall moves up, but thrust faults are at a much more shallow impact angle. Some thrust faults found within the series are the Lewis Thrust and the Volcano Valley Thrust and the Willow Creek Thrust Zone. In the picture, you can see that the crust underneath the Lewis Fault is uplifted from the two fault plates being compressed.
Thrust faults have also been the cause of the Rocky Mountain Trench. Since the hanging wall moves up, it creates folded mountains, but when the land is folded over, it creates a steep side to a trench. The reason it becomes a trench is because the crust of the footwall is not forced backed up on the other side. In addition to the thrust faults, most of the belt series have been carved by glaciers, which creates U-shaped glacial valleys and other glacial features such as horns, ariets, cirques, and tarns. Examples of these can be found in Glacier National Park, which makes up most of the belt series. The glacier that carved the belt series ended during the tail end of the Pleistocene era.
The belt series formed in the Precambrian ion, specifically the end of the Archean area, which is around 2.5 billion years old. Within the history of the belt are various rock types, sediment types, erosional features, and faulting. The history is split into four major groups: the lower belt as the oldest, the Ravalli group, the Pagan group, and the Mazzola group as the youngest. The lower belt mainly contains metamorphic rocks such as biotite. There is also a base layer of Paleoproterozoic crystalline, which is believed to have come from the eastern Australian craton. Some sedimentary layers of mudstone later appear in rock life. The lower belt has heterogeneous to fine-grained clastic and carbonate rocks. Studies on these rocks have revealed that the lower belt was formed by deep water deposition and has evidence of sedimentary facies. Sediments from the southwest have also been found, as well as mafic sediments like basalt.
The Raviali group, largely subaerial clastic wedge, deposited sands and muds, mostly fluvial. Near Idaho rocks are light color and silicaceous, ranging from pure white quartzite to siliceous shale, mostly in subdued tones of gray, green, purple, and red. The Pigeon group consists of cycle carbonate siliciclastic. It's also part of the middle belt. Carbonate must alternate with a limonate of clastic muds, divided to be equivalent to each other.
The Mazzola group is the youngest group and contains fluvial clastic wedges that were derived from the south and from a river system. Fluvial sands and muds can also be found within this group. Generally, it is known to be sandy and have quartzic hygrolite, impure quartzic hygrolite, or limestone. There are some resources to be found and some hazards to be found as well within the belt series. There are valley-filled aquifers in the northern area. That are unconsolidated, but the water is found in between pore spaces. There is no hydrogeologic activity or geothermal activity because the rocks below are too thick. However, there are risks of earthquakes within this belt series because they are an intermountain seismic belt. The folds are There are folds around Yellowstone tectonic parabola, and these are where the earthquakes occur. And these are our resources. Thank you for your time.